So in the last class, we studied about the defects in the solids, right? About the imperfection in the solids and what are the different types of defects. Okay, about the stoichiometric, non-stoichiometric, impurity defect. So all this as we have covered in the last class. And in the last, electrical properties of the solids also we covered in the last class. So again, under the electrical properties, we have the conductors, semiconductors, and the insulators. Conductors means what? Which will conduct the electricity perfectly. That is the conductors, which will have the conductivity range from 10 power 4 to 10 power 7 ohm inverse meter inverse. Next, semiconductors. What is the meaning of semiconductors? They have conductivity range from 10 power minus 6 to 10 power 4. So if you add any impurities, they will undergo some, they will increase their conductivity. That is what called as semiconductors. And insulators. What is the meaning of insulators? They will not conduct the electricity at all. So they have the conductivity range from 10 power minus 20 to 10 power minus 10 ohm inverse meter inverse. Okay, these are the insulators. So again, these they are extended with the help of the band theory. So in the band theory, they have taken the two bands. One is a conduction band, the other one is a valency band. So when you take the conductors, the valency band and the conduction band are almost close to each other. Whatever the gap is there between these two, it is very less. And this gap we will call it as a forbidden gap. So in the case of conductors, this forbidden gap is very small. So the electrons will move freely from valency band to conduction band. Understanding?
Yes, sir.
Okay. Now, next one. In the case of semiconductors, the forbidden gap is little bit higher than the conductors. So it has an energy gap of 1.5 to 3 volts. So only few electrons will move from valency band to conduction band. So it will conduct only the partial amount of electricity. And the last one is the insulators. In this case, there is a large gap between the valency band and the conduction band. So the energy gap is greater than 3 volts. So they will not conduct the electricity at all, because what is the main reason? What is the main reason according to the band theory? Why insulators will not conduct the electricity according to the band theory? What is the main reason? Because the gap between these two bands is very, very large. So the electrons will not jump from valency band to conduction band. That is the main reason for the showing of this property in the case of insulator. The conductivity is very, very small in the case of insulator. Now, what is the meaning of doping? Sorry, I asked you to study the elements in the group wise, right? Have you done the homework?
Yes, sir.
Have you done anyone group 1 elements? What are the elements are there in the group 1? What are the elements are there in the group 1? There, yeah. Neha, Vishwanath. Okay, at least P block elements, group 13 to group 18. Already I have written the group 13 to 15 here itself. The remaining three more groups are there, 16, 17, 18. Any one of you can tell me the answer. Unmute yourself and you can give the answer, right? Unmute yourself. So group number 13 elements are boron, aluminum, gallium, indium, thallium. All these will have the +3 oxidation state. Next, group number 14 is the carbon, silicon, germanium, tin, lead. All this will have the +4 oxidation state. And group number 15 is the nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, all this will have the +5 oxidation state or +5 valency electrons. So when you take the group number 14, like silicon, germanium, these are the semiconductors. If you dope the group number 14 with the group number 13, it will cause P type of semiconductors because group number 13 is the electron deficiency or electron deficient impurities. When you are doping the group number 14 with the group number 13, it will cause the P type of semiconductors. And when you are doping the group number 14 with the group number 15, it will cause the N type of semiconductors. Because group number 15 is the electron rich impurities. Okay. So this is what we studied in the last class. So any doubts in the semiconductor topic? If you don't have any doubts, we'll go for the next one. So next one is the magnetic properties. So to take the magnetic properties, again, whatever the solids are there, it will classify into the 5 different types: paramagnetic, diamagnetic, ferromagnetic, antiferro, and the ferrimagnetism. These are the 5 different classification of the solids into the based upon the magnetic behavior. So just we'll study the entire thing in one tabular column. So first one is a property, then description about that magnetism, Next, alignment of domains. And the next one is the examples. So first one is the paramagnetism. What is the meaning of paramagnetism? Anyone? What is the meaning of paramagnetism? So whenever there is an unpaired electrons are there in the given solid, it will cause the paramagnetism. So paramagnetism is a magnetic property which is occurred due to the presence of unpaired electron in the given substance. Unpaired electron present in given solid will cause the paramagnetism. Okay, so if you keep this in the magnetic field, it will be attracted in the presence of magnetic field. If you keep the substance in the magnetic field, it will get attracted. In the magnetic field, what will happen? It will be attracted. Okay, once you remove this substance out of the magnetic field, it will lose the magnetism. That means until this substance keep it in the magnetic field, it will act as a magnet only. So what you can say, it is a temporary magnet. Okay, so these are the important description about the paramagnetism. Paramagnetism is what? Substance which has a unpaired of electrons will cause a paramagnetic behavior. So when you place these substances in the magnetic field, it will get attracted and it will act as a temporary magnet. That means in the presence of magnetic field, the substance will act as a magnet, but in the absence of magnetic field, it will lose its magnetism. Okay. So what is the meaning of domain? Means the group of particles or group of unpaired electrons is called as a domain. So when you take the domain here, paramagnetism will show the domain in the same direction. All will show only in up arrow in the presence of magnetic substance. So in the presence of magnet, all will show only in the upper arrow or in the same direction. So example is the O2 oxygen. So this oxygen will show the paramagnetic behavior, which is explained based upon the molecular orbital theory, which you'll study in the chemical bonding in the class 11th. So even though it has the even number of electrons, the oxygen will act as a paramagnetic behavior. That is what explained mainly in the molecular orbital theory in the class 11th. So O2, CuO, TaO, these are the paramagnetic substances. The next, diamagnetic. Anybody, what is the meaning of diamagnetic? What is the meaning of diamagnetic? Anyone? Hmm? What is the meaning of diamagnetic? Good. Vishwanath. It is the shown whenever it is having the all the electrons are paired up, it will show the diamagnetic behavior. When all electrons are paired, when all electrons are paired in the given substance, it will show the diamagnetic. That means no unpaired electrons. So if you keep it in the magnetic subfield now, what will happen? It will attract, it will repel. It will repel in presence of magnetic field. Okay. So it will repel in the presence of magnetic field, and whatever the domain is there, it will be in the opposite direction because it will form unpaired electrons, right? So all the domains will cancel out each other. So it will form the zero spin. Example is TiO2, Au, Ag, V2O3, NaCl, and C6H6. So these are the examples for the diamagnetic substance. The next one is a ferromagnetism. What is the meaning of ferro? Anyone? What is the meaning of ferromagnetic substance? So these are the strongest magnets out of the 5 different types of magnets. Okay. So ferromagnets are the strongest magnets, are the permanent magnets out of the given 5 magnets. Okay. So it is a permanent magnet. So it will have the domain perfectly in only one alignment. And if you remove the substance in the presence of magnetic field also, they will act as a permanent magnets. After removing from magnetic field, still they will act as a permanent magnets. Still they will show magnetic behavior. Okay. So best examples are the iron, nickel, cobalt. So ferromagnets are the strong magnets and also called them permanent magnets. They will not lose the magnetism easily compared to the remaining things. So whatever the permanent magnets are there in the outside wall, they are made up of ferromagnets only. The next one is the antiferro. Then what is the difference between ferro and ferro? Antiferro? Only the arrangement of the domains. In the case of ferro, they have all the domains will be in the one direction. But in the case of antiferro, all the domains will be exactly cancel out each other so that the net dipole moment will be equal to 0. Okay, so net magnetic moment is equal to 0 in the case of antiferromagnets. The net magnetic moment is equal to 0 in the case of antiferromagnets. It is also MnO2, MnO, and FeO. All this will show the antiferro. And the last one is the ferrimagnetism. So here the difference is in the case of ferromagnetism, all the domains are in one direction. In the case of antiferro, all the domains are in the different direction, but the number of positive spins is equal to number of negative spins, so that overall magnetic momentum will be equal to 0. In the case of ferri, what is there? Whatever the spins are there, they are not equal. So one will be up now, both will be down. Again, one will be up now, both will be down, like this. So unequal number of spins will be there, so that the magnetic momentum is not equal to 0. Magnetic moment is not equal to 0. Parallel and unparalleled spins are not equal. So example Fe3O4 and the Fe3O4 is best. Just wait a minute. Okay. So ferrimagnet is the Fe3O4. So these are the different magnetic behaviors. So paramagnetism, which is caused due to the unpaired electrons present in the given substance. So alignment of all the domains are in the same direction in the case of paramagnetism. And best examples are the O2, CuO, and the TiO. So these will act as the temporary magnets only. In the presence of magnetic field only, they will act as the magnets. In the absence of that, they will not act as a magnets at all. So next one is the diamagnetism. So next one is the diamagnetism. When all the electrons are paired in the given substance, we will form the diamagnetic substance. So it is caused due to the no unpaired electrons. So whatever the domains are there, they will be exactly opposite to each other. And ferromagnets are the strong magnets and also called as permanent magnets. All the domains will be in the same alignment in the presence of magnetic field. So when you remove this from the magnetic field also, they'll act as they will show the magnetic behavior. Best examples are the iron, nickel, cobalt, and the antiferro. Both are same ferro and antiferro, but in the case of antiferro, there will be both the spins, parallel spin and the unparalleled spin. Means positive spin and the negative spin will be there, and both are equal only. So this is a antiferro. So that net dipole moment is equal to 0. And the last one, ferrimagnetism. Here unparalleled and the parallel spins are not in the equal quantity. So they will show the magnetic momentum. This and all is the explanation part about the magnetic behavior in the solids. But when you heat these solids, like ferromagnetic solids and ferrimagnetic solids, they will become the paramagnetic substance. They lose the magnetism. When you are heating these ferro or the ferri or the antiferro, they will lose the magnetism property and they will become the paramagnetic substance. So any doubts in this topic? Just go through it once again, complete tabular column and ask me any doubts are there in this. Can you see it clearly? This is a complete tabular column about the magnetic behavior. Any doubts? So with this, we have finished the theory part of this chapter. This is the last topic in the chapter. So next we'll do only the numerical parts from this topic. And one tabular column I will give you in the next class. I'll explain the tabular column, which is very important for the competitive side. So if you have any doubts in this topic, now you can ask me. But first unmute yourself. Any doubts? Or should we go to the problematic part? Didn't reply, Vishnath. Shall we go to next topic or shall we discuss this again? Neha? Give me the reply, please. What about Dhairya and Vishwanath? Okay, just I'll write give you one problem. You just tell me the answers. Next one. So on doping, germanium metal with a little of indium or the gallium. One gets A. P-type semiconductors, B. Insulators, C. N-type, and D. Rectifier. What is the answer? When you are doping the germanium with a little of indium or the gallium, what you will get? Hmm? Give the answer, please. Very good, Vishwanath. What about others? Neha? Sorry, Jafar and Dhairya. What are the answers? When you are doping the germanium with a little of indium or the gallium, which type of semiconductors or the rectifier will get? First, germanium belongs to group number 14 and indium and gallium belongs to group number 13. So whenever the group number 14 is doping with the group number 13, it will form the P type of semiconductors. Okay, so option A is the correct. It will form P type of semiconductors. Next one. So which defect? Sorry, not which defect. When electrons are trapped into crystalline anion vacancy, then defect is known as option A, stoichiometric defect, option B, Schottky, option C, Frankel, option D, absenters. When the electrons are trapped into the crystalline anion vacancy, then defect is known as What is the defect name? What is the defect name? When the electrons are trapped in the crystalline or anionic vacancy, the defect is known as. What is the defect name? Stoichiometric defect, Schottky defect, Frankel defect, or the F-centers. Give me the answer, please. Or if you don't know, just tell me don't know or type the message. You don't know. Already have discussed this complete defect theory in the class. And this question is very important. It already came 3 to 4 times in the previous year board exam and in the competitive side also. What is the answer? Yes, you can guess the answer. I can give the message to me, direct message. First, are you understanding what I'm teaching or not? So what is the answer? The answer is F centers. The F centers are the Fairbairn centers, which will impart the color to the given crystalline solids. So F centers are formed when the given anion goes to the surface of the solid, and from the surface, the electrons will occupy the anionic side in the crystal. So whenever the electrons is occupying the anionic side in the crystal to maintain the electrical neutrality, the center is called as an F center or the Fairbairn center, which will use the color to the crystalline solids. Okay. Next one. Suppose in the case of diamagnetic substance, whether it will be attracted by magnetic field or repelled by magnetic field. Like diamagnetic substance, is it attracted by magnetic field or repelled by magnetic field? Good, Vishwanath. It will be repelled by the magnetic field. When you take the diamagnetic substance, if you place the diamagnetic substance in the magnetic field, it will be repelled by the magnetic field. Okay. Now, electromagnets are the will consider the paramagnetic behavior or dia or ferro or antiferro. Electromagnets will consider what? What type of magnetic behavior? If you take the electromagnets, what is the meaning of electromagnets? When we pass the electricity only, they will act as a magnets. When you are not passing the electricity, they will not act as a magnets, right? So electromagnets will show which type of magnetic behavior. It will act as a paramagnetic behavior because whenever you pass the electricity only, it will act as a magnet. Apart from that, it will not act as a magnet. So we'll consider the paramagnetic behavior. So with this, we finish this chapter. In one more class, we'll do some numericals for the JEE on the whatever the remaining topics are there, or from the entire chapter, we'll take some more numericals, and one tabular column will be there on this chapter about the structures, fluoride structure, anti-fluoride structure, zinc blend, and all. So within next class, we'll finish this chapter and we'll start the next chapter solutions. Okay. So if you have any doubts, you come up with the doubts in the next class, we'll solve it. Fine. With this, I'm going to end the session here today.